All right, let's jump right in. Today, we're talking about a massive architectural shift that's going to define the future of digital security. We're talking about quantum-safe APIs, and why building for resilience isn't really a choice anymore, it's an absolute necessity. Let's get into why.
You know, for the longest time, quantum computing sounded like something straight out of a movie. Pure theory, stuck at a lab somewhere. But that's just not the case anymore. The reality of powerful quantum computers is getting closer and fast. And they are poised to completely rewrite the rules of our digital world.
And here's the real kicker. This isn't some far-off problem for data that doesn't even exist yet. Nope. The technology of tomorrow is a direct threat to the encrypted information we are all creating and sending right now.
So, to really get a handle on this, here's how we're going to break it down. We'll start with the quantum threat itself, then we'll look at a sneaky attack called Harvest Now, Decrypt Later. After that, we'll introduce the solution, the quantum-safe API, and outline a blueprint for building one. And finally, we'll talk about why this is becoming the new baseline for all digital trust.
Okay, let's get right to the heart of the problem. You have to realize the entire foundation of our digital economy, every secure transaction, every private message, it's all built on a foundation of trust. And that foundation, well, it basically has an expiration date.
So, on one side, you've got our world today. It's built on these incredibly tough cryptographic standards, things like RSA and ECC. They're based on math problems that are just about impossible for our current computers to solve. But for a quantum computer, as you can see on the other side, those impossible problems become totally solvable. And that means the very locks that protect our entire digital lives are going to shatter. Okay, so if quantum computers are still a little ways off, why the huge rush? Why is everyone so worried right now? Well, this next part explains it. The threat isn't just in the future, it's happening now, thanks to a simple, patient, and really effective attack strategy.
So here's how it works. Step 1. Adversaries right now are hoovering up massive amounts of encrypted data. They can't read it, so they just store it. Step 2. They just wait. They don't need a quantum computer today, they just need to know one is coming. And then step 3. Once they get their hands on that quantum power, they can go back to that treasure trove of data and unlock all of our old secrets. We're talking financial records, government secrets, healthcare data, everything.
This is where we shift from doom and gloom to the solution. If the old locks are all going to break, we obviously need new ones. And in the world of modern software, that new lock is the quantum-safe API.
The technology powering these new APIs is called Post-Quantum Cryptography, or PQC. Think of it as a whole new class of cryptographic algorithms. They're built on totally different kinds of math problems, things like lattice-based crypto, that we're pretty confident are tough for both regular and quantum computers to crack. So really, when it comes right down to it, a quantum-safe API is an interface that's been designed from the ground up to use post-quantum cryptography. The whole point is to architect systems that can defend our data not just today, but for a long, long time into the future.
So what does it actually take to build one? I mean, it's not as easy as just flipping a switch. It's really about adopting a new set of core principles for how we engineer things.
Building this kind of resilience means using a few key strategies. First, obviously, is swapping out the old, vulnerable algorithms for new post-quantum ones. But we can't just do that overnight. That's where hybrid handshakes come in. It's a clever method that uses both the classic crypto we trust and the new PQC stuff, giving us the best of both worlds during the transition. We also do things like use short-lived secrets to minimize risk. But maybe the most important idea here is building for crypto agility. All that means is designing our systems so we can easily swap out crypto algorithms in the future without a massive redesign. It's about making sure we can adapt as new threats and better solutions come along.
Now, it might be tempting to look at all this and think, wow, that seems like a lot. Isn't this just over-engineering? But the final, and maybe most important point here, is that thinking that way is already becoming outdated. And this quote just nails it perfectly. Think about it. 20 years ago, HTTPS was kind of optional, right? A nice to have. Today, it's the absolute non-negotiable standard for trust online. Quantum-safe security is on that exact same path. It's quickly becoming the new default expectation. So, who needs to be acting on this like yesterday? Well, pretty much any API that handles sensitive data that has to stay secret for years. We're talking about finance, identity systems, healthcare, blockchain, cloud infrastructure, and of course, government. The risk of waiting is just getting too high. And all of this leaves us with one last thought. The decisions we make today, in the code we write and the systems we design are going to have consequences that last for a very long time. So the question you really have to ask yourself is this: are you just building for the next release, or are you building for the next decade?